So, hello everyone. My name is Olsson, and I run a company in Sweden called Follou. We've been a company for say 3 years around now, and we have spent some time developing a haptic device and some accessories to this haptic device. And we have made a system which we call haptic avatar. So it's a force feedback device interface system for laparoscopic, arthroscopic, thoracoscopic training simulators mainly, which has 4 degrees of freedom. So it's for minimal invasive surgery. And we have 3 key features that we would like to highlight with this product. And it's the slim and contained design that allows for modularity, I think, in a way that you haven't seen before. And that the instruments that you use together with a haptic device is independent from the device, and you handle them in a different way. Also, you have force feedback in all degrees of movements here, so there is no shortcuts. So I'm going to jump straight into the hardware here and show you. Maybe some of you have already tried the device over in our booth, but I will give you a more detailed presentation here. So first of all, we have an instrument insertion port part here that is supposed to be in the size of a trocar, a port that you use in laparoscopy. And this is where you insert the instruments, and it has a quite slim design around this insertion port, which means that you don't have any mechanics below the pivot point. You have 4 degrees of freedom, movement freedom. You have a side-to-side movement, you have a back and forth movement, and you have insertion of the instrument, and you also have rotation of the instrument. We have made the range for the side-to-side movement quite large. You can tilt it 90 degrees like this, and 90 degrees like this. Now you have plus minus 60 in the back and forth movement. So this is also something quite new in this field. You have the opportunity to have a device that has a flipped direction. I will show you later on in a setup. We have return springs inside here, which are mechanical, which means that you don't have to worry about these instrument ports falling inside. And when you have a trocar inserted in the abdomen, it will be a natural spring force in that incision. We have, as I said, it's a contained product in the sense that everything is included in one device. We have the power with batteries. We have the motor amplifiers. We have the controller for the motors. And we also have a cooling arrangement inside here. So when it gets a little warm, a fan will start cooling the amplifiers. That doesn't happen very often, but it's there. So what you do is that you plug this into a USB in your computer, and you're actually up and running. You don't need to have a separate power supply, for instance. You just the power comes from inside. Now and then you have to recharge the batteries, but it's quite seldom actually. you have a quick connector plate, which means that you can, we have choose just to make a simple setup for this demo here, where we have made a simple ramp on a wooden plate, and then you can just release the device from the plate like this. So this is the product. This is the haptic device, and this means that it's simple to set it up for a procedure, laparoscopic procedure. You can place the devices next to each other, only 50 millimeter apart, and you can mount them on top of a plate. You can have them on a ramp like we have. You can have them mounted underneath and have this portal part flipped. And if you need to charge them, you can take them off. You can take them to a charging station. If you want to make a different setup, if you have a set of setups for laparoscopy, you can rearrange them very quickly. I will show you a number of examples on setups. So you just put it on this black plate, and you snap a little lever in the back, and then it's fixated. We have the instruments that we have. They're based on simple threaded rods. They're actually they're called ACMA lead screws, used for positioning. So simple rods that has two grooves, two machine grooves, and this is for grabbing the tool lengthwise and rotational wise. Each tool has a tip in the end of it, and this tip is used for identifying the tool type. So, for instance, this tool has type number 7. So when I insert my tool into the device, it will detect that this is tool number 7. This means that you don't have to make a specific selection in a GUI. If you're a user, if you're a trainee, for instance, you want to focus on the different procedural steps that you have in the simulation. You don't want to choose an instrument from a GUI between between the steps. So let's say that, for instance, you perform a dissection, or you perform coagulation of the surface tissue with a bipolar forceps, and you pull out the bipolar forceps, and you take a scissor, and then you put in the scissor, and if you repeat this step several times, then you know that the GUI will be in the way, so to say, from the procedural steps. You want to have a detection of the instruments, and this is what you get with this tip that you have here. And we have this insertion part is lit up with the LED, so you can give the trainee kind of guidance for, let's say that you want to the trainee to insert an instrument in this particular portal. You have several portals, say, then you can light up this insertion part. So the instruments, they are connected to a separate box. So all instruments that has some kind of sensing, like a grasper, where you want to measure the handle movement, they connect to the instrument box. So the instrument box, in turn, is connected via USB to the host computer. And this means that you can have as many instruments as you want, because you can have many instrument box, but normally you don't need more than 6 instruments to a surgical procedure. Because there are also some passive tools that you use, like a suction irrigation tool that doesn't have any interaction, that comes in addition to the 6 ports that you have here. Also, this is contained and has integrated motor amplifiers, controller, and cooling. So, and also has a quick connector plate, which means that you can take this one away and put it on the next setup if you want. There is also an input for a double switch pedal, which is often used in different surgical simulations. We have 2 tools developed right now. We are working on more. One of them is the camera. The camera is special in that sense that it has more sensing than the normal grasper. So we have a zoom button, we have 3 universal buttons, and we also have a sensing of the angle of the camera, camera rotation relative to the scope. Because if you're using a scope with a 30 degrees lens or a 70 degrees lens, then you have to have control over the camera rotation as well. Oh, sorry. So this is the grasper handle, and this one also has force feedback. This particular one doesn't have force feedback, but the other one over there has force feedback. So when you move the handle, it will detect the motion, it will send the signal to the host, and when you calculate the forces, when you're grasping something, you will also feel the force in the handle. And it's quite strong, actually. You can have up to 25 newtons in the handle. And you are strong in the hand, and you need to have forces, quite high force, when you're doing a surgery. When you do a cutting, for instance, with a scissor, or when you're holding a tissue with a grasping forceps. So this is what a system would look like. You have the host computer, you have the USB host, you have the number of devices that you want to have, you have an instrument box, you have a pedal, you have a number of tools that is necessary for the setup of the procedure, and you also have a camera. The camera is connected separately to the USB port. And you can have many cameras, you can have quite a lot of instruments. So right now we are working on a plugin to SOFA to be able to use the haptic devices from here. So it's easy to start working with a device. And we are taking help from Mr. Eric Bernot, Infinitec 3D. So this is one example of how a desktop workstation for laparoscopy would look like, can look like. You can do it in so many different ways. This is some kind of IKEA example. You put some kind of base. You have a wooden base, and you have some kind of structure for holding the laptop. And you put these mounting plates that I showed, the black mounting plates, underneath this plate here, and you attach the devices underneath, and you attach the instrument box like this, for instance. This setup would be quite simple to transport. You could have it, you almost have a separate laparoscopic workstation on your desktop as a developer, and this is quite neat. A second example is if you want to do shoulder arthroscopy. This is a specific example because shoulder arthroscopy is made often in two different type of positions depending on the preference of the surgeon. This is a lateral decubitus position, and this setup could mimic this procedure. And you could easily switch to a different position. The beach chair is a different setup in shoulder arthroscopy. For knee arthroscopy, it's special in that sense that the surgeon needs to flex and bend the knee in different directions to be able to reach the different compartments of the knee. Because if you bend the knee sideways, you will open up the compartment under the medial meniscus. And if you flex the knee, you will be able to see more of the patella, the hard part here. So you could quite easily make a joint, a plate that has a joint, and put two devices on that plate, and you can even have a sensor in that joint, and then you can simulate the flexing of the knee. And this is very often arthroscopic surgery are quite complicated in that sense that you have many ports, many trocars for one procedure. This is, I think, a bariatric procedure where you have 5 ports. And this is where the flexibility of this device and setup comes to its right. We have made our own plate at home, so in our company, where we have a plate with rails. These rails, on these rails, we have ramps. The ramps, you can push a lever and release the ramps from the rails, and you can move them lengthwise. And you can take a device with a ramp, you can flip it and put it on the other in the other direction. And this means that you can put them very close together, and you can also put multiple portals. So we have this set up in our office, and we also have a mannequin, a simple mannequin, a man in a wetsuit. So this is what we think Havatar brings to the table: full force feedback, full movement, instrument identification, also force feedback in the handle, and this modular and slim design makes positioning on portals and having multiple portals very easy. The current status in our development right now is that we are working on the plugin to SOFA, and we're going to start evaluating that early next year. And for production, we think that we have a stable version somewhere in Q2, say April, March, May next year. Yeah, so that's it.
Thank you, Frederick. Again, yeah, I think I'm very happy to see that kind of, it's first product after I guess years of prototyping at Follou, which comes coupled with SOFA. So I think it's a super nice opportunity, especially obviously in the field of medical simulation. Is there any questions on the haptic device from Follou? Yeah.
Do you also have a version without haptic feedback, actually, just for tracking? As you see, you've shown on the laparoscopic with 3 trocars and 1 for the camera, and most of the time on the simulator, this one's not with haptic feedback. Have you done? We don't have it yet, but it's quite simple to take that step back, so to say, for just having sensors for motion, and it could be smaller than the version with the haptic.
Maybe I didn't catch it, but really just a very direct question. Is that ready to sell already, or?
In a prototype version, maybe, yes. If someone is patient enough to have some trouble with it. We don't know yet. We haven't stress tested it yet. It works quite well, but we haven't stress tested it. So, and we haven't CE marked it yet. So this remains, and we have most of the mechanical work that we have in front of us is related to production, and to make it as cheap as possible and as simple as possible for the assembly.
As a price tag, can you give us an idea of how cheap?
Yeah, we don't have an official price tag, so perhaps we have to do like Tesla or so. I don't know. But maybe it's better to say what the maximum price is, and then we are working on having a price lower than 5,000 euro. We want to have it lower than that. So let's see where we end up.
Okay, thank you again. If there is other question, I mean, obviously you can test everything and really assess what Frederick just explained you and presented you directly live. Just before, so next presentation will be presentation of Infinitec 3D. Thank you again, Frederick.